Alright, hey AP Chemistry. I wanted to post a brief, or maybe not so brief, video on using ice tables. And so I want to review a little bit about maybe naming acids, how I would write a dissociation equation, and then how I would go about using or creating an ice table. Okay, so let's say I have this acid. It is H3PO4 aqueous. If you remember from nomenclature or naming, PO4 has a charge of 3 minus. This is called the phosphate ion. So PO4 is phosphate. And then of course, if I have a hydrogen in front, this kind of has my acid structure, HA, where A is some conjugate base or some negative charge, and H is my acid. This is an acid, so to name phosphate as an acid, I change the ATE ending to oric, and it'll be named acid. So this is going to be phosphoric acid. Okay? Alright, so this is known as phosphoric acid, and if you do watch this video tonight, you will get a head start on talking about phosphoric acid tomorrow and later. If I want to write the dissociation equation, typically the dissociation equations have the form HA in equilibrium or breaking apart into H plus A minus, right? So I have HA, there are assumed to be two ions here. I have an H, and I know that H is a proton. H is always H plus for us now in acid-base chemistry. And if this is H plus 1, that must mean this is A minus 1. So that dissociates into two different ions. Now in the case of phosphoric acid, there's something a little bit different about it. I have 3 H's here. So if this were going to dissociate, I would have 3 H pluses that dissociate. And so I'll have 3 H pluses, and these are going to be aqueous, because there's 3 H's in here, and each of those H's are H plus. And then the other thing that's left over that dissociates or breaks off is PO4, 3 minus. Okay? So there's my dissociation equation. And now let's see how I would do a question for an ice table. Let's say I have an initial concentration of phosphoric acid at, let's say initial, it's initially at 1 molar. All right, and now in the ice table, we could use molarity. When we've done tables like this before, we did BCA tables and you could use moles. You could use moles in the ice table as well, but you gotta be careful. Later on, you convert that to molarity if the question asks for concentration. So let's say I had an initial concentration of phosphoric acid as 1 molar, and then I tell you that at equilibrium, my concentration of phosphate was found to be 0.025 molar at equilibrium. And these are things I tell you. This is kind of like when we did BCA tables and I had how much stuff before, and then I was either trying to figure out how much stuff after, or I tell you how much stuff is after. So if I want to begin to write my ice table has 3 columns. Okay, I'm going to erase a little bit of this so we have room. 0.025 molar. Alright, so if I do my ice table, ICE, this is like my BCA table, so instead of it being B for before, we instead use I for initial, instead of using before. So go back to our notes on BCA. Instead of using BCA, we're going to use ICE. I is initial, C is for the change, and then in this unit and chapter, with these double arrows for the dissociation, this is equilibrium. And how do I know this reaction's at equilibrium? Well, phosphoric acid is a weak acid. It is not on my strong acid list, and I'm telling you that it does not fully dissociate. So since I know now, since I'm telling you right now, I didn't tell you earlier, since it does not fully dissociate, it will be in equilibrium. And so I told you in the beginning that my initial concentration of phosphoric acid was 1 molar. So my initial concentration was 1 molar. And then I told you in the end that I found out that at equilibrium, my concentration of PO4 was 0.025 molar. Okay? And I forgot to add in these rows. I need a box for each section, right? So I have my I goes in the top, C in the middle, E across the bottom. And then I have my 3 columns for my 3 different species, my H3PO4, my 3 H pluses, and my PO4 3 minus. So there's where the 3 by 3 comes in. Now in the end, I tell you that my equilibrium concentration was 0.025 molar. Now I have to figure out everything else. Okay, so how do I do an ICE table or a BCA table like this? Well, this had to have come from adding I and C together. Right? I add my initial to my change and I'll get my equilibrium. What you should know is that initially I should have no products. Right? Initially everything is an H3PO4, so I only have 1 molar of H3PO4 before dissociation. Then eventually dissociation occurs, and that's where my change in equilibrium happened. So initially these are 0. But then I tell you that at equilibrium, I'll have a 0.025 molar concentration of phosphate. That means that I had to have added 0.025 molar. That's where I put the change in. The change comes from my equilibrium. So this number goes here as positive 0.025 molar. Okay, so if you're wondering where these middle numbers come from, they come from either given in the change or given in equilibrium concentration, or given in the after. And so this is added to 0. The only way I could get positive 0.025 molar is if I added 0.025 molar. Now here's where the tough part comes in with stoichiometry. Change is all about using stoichiometric relationships. Okay? So you need to know, or you need to just look at a chemical reaction and go, oh, that is a 1-to-1 mole ratio, or that is a 3-to-1 mole ratio. You need to be able to look at that. So if I look at this balanced chemical equation, and let's just assume it's balanced, and it is because I made it, I only have 1 H3PO4, I have 3 H's that get made, and 1 PO4 3 minus that gets made or broken apart. Remember, if I don't put a number in front of a compound, we assume that it has a coefficient of 1. So the way I could read this balanced chemical equation is for every 1 molar, or 1 mole, I could use those interchangeably, for every 1 molar of H3PO4, I should get 3 molar H plus and 1 molar PO4 3 minus. Same idea with mole ratio. For every 1 mole of H3PO4, I'll make 3 moles of H plus and 1 mole of PO4 3 minus. Now if I made 0.025 molar of PO4 3 minus, I could figure out how much H plus was also made. Looking at my balanced chemical equation here, what is my mole-to-mole ratio of H plus to PO4 3 minus? Looking at it, there's a big fat 3 here. So for every 1 mole of PO4 3 minus, I will get 3 times as many H plus. It is a 1-to-3 ratio. So if I have 0.025 molar PO4 3 minus, I'm going to have to multiply by 3 to get how much concentration of my H plus. If you don't understand why I'm multiplying by 3, I could just set up a simple proportion. So for every 1 mole of PO4 3 minus, there are 3 moles of H plus. Okay? That's equal to, right, I'm setting up my proportion, 0.025 molar, right? And I could use molar, so let's say 1 molar instead. I could use molar. It's all in this, we're assuming it's all in the same volume. Remember, molarity is equal to moles over liter. This is all happening in the same container. Why? Just assume it's all happening in the same container. I didn't say anything about volume, so we're going to assume it's the same. And so if I have 0.025 molar of PO4 3 minus, I have to solve for X molar of H plus. If I cross multiply and divide, X is going to be equal to 3 times 0.025 molar. that means X is equal to 0.075 molar of my H plus. So that goes here. That's why I'm multiplying by 3. So I got plus 0.075 molar H plus. And it's plus because I'm making them. Okay? And then if I want to have my equilibrium concentration, I add my initial to my change. So 0.075 molar. And now I could figure out how much of my phosphoric acid is left over at equilibrium. If I made 0.025 molar PO43 minus, that had to have come from the H3PO4. I'm going to use the simple 1-to-1 mole ratio. For every 1 mole of PO43 minus, I needed 1 mole of H3PO4. So if I made 0.025 molar of PO43 minus, I must have made, it's a 1-to-1 ratio, I must have made 0.025 molar at equilibrium. Okay? I could do this with H plus as well. For H plus, oh, I'm sorry. Oops, I made a little mistake here. That only goes over here. I must have used, if I used 0.025 molar of PO43 minus, I must have used that much, 0.025 molar. That's my mistake. I need to use I and C to get E. I don't know what my equilibrium concentration is because I started with 1 molar. I just made a little mistake. So make sure you follow that mistake. In the change, that's where I use my mole to mole ratio. So I'm going to make a note of that so you're not confused by my mistake here. So I only use the mole to mole ratios in the change section. So again, if I made 0.025 molar of PO43 minus, 1-to-1 mole or 1-to-1 molar ratio, if I made 0.025 molar, I must have used 0.025 molar. And I'm subtracting it because I always subtract from my reactants. I subtract for reactants because I'm using it. Reactants get used up. And I add for products because I'm making my products. Okay? And so now I could do 1 minus 0.025, and that should be 0.975 molar. Okay? That would be my equilibrium concentration. So please be careful of my silly mistake. I put it in the wrong box. I did not make 0.025 molar of H3PO4. I only used it. So I use my change section with my mole to mole ratio. So to repeat one more time to fix that mistake, I know where I got these two numbers from. I made 0.025 molar of PO43 minus. That means I must have used in the change I made up 0.025 molar. My mole to mole ratio of PO4 to H plus is 1-to-3. So that means I must have made 3 times as much H plus, which is 0.075 molar. And then again, my mole to mole ratio of PO4 to H3O4 is 1-to-1. So if I made 0.025 molar, I must have used 0.025 molar. Now if you don't use the 1-to-1, it's the same thing. I'll get the same answer if I use the 1-to-3. If I made 0.075 molar H plus, I must have used 1/3 of that 0.075, or 1/3 of my phosphoric acid. So if I made 0.075, 1/3 of that, which is 0.025, is how much I used. And then finally, where we're going to see these calculations is if I want to calculate KEQ. Remember, KEQ is the concentration of products over the concentration of reactants. So I would just put my expression of H plus cubed over PO4 minus all over the concentration of H3PO4. If I plug in these numbers, I'll get my answer. Okay? So hopefully this video helped. Sorry for that little mistake, but I'm going to show it in there just so we know we all make that mistake. If you have any other questions or concerns about using ice tables, please let me know.